My name is James from Linux Accra. So today we are going to discuss about the DNS, how it works from the recording to resolution. So we cover a few steps in this part, which is here we are going to talk about the idea of DNS and how it works. What is DNS exactly? And then we talk about what we call records. So each DNS has a record, and then we give a hands-on on how to look up DNS results. And then we talk about the public resolvers that we have available, and then how to configure it on your devices. And then lastly, we talk about how to set up your own on your own Linux device. So we start off with what's a DNS. So the full meaning of DNS is domain name service, which is a domain name service which keeps a record of IPs. So when the computer started, when the internet started specifically, we had IPs, which is what the machine understands. So we have the IPs, and it's like a phone book. We all have phone books. So instead of we remembering the IPs, which are numbers, which would be very difficult for humans, we invented DNS. So the DNS links the names that we human can understand to the IPs. So when you say you're visiting google.com, so a domain name, which is google.com, has an IP, which is pointing to the wherever server it's being served from. But since we can't memorize these IPs because they are numbers, we have google.com. And then when google.com is passed to a DNS server, it returns the result to the IP of the domain. So that's what DNS is. So whenever you visit a domain, you type in whenever you type in a domain on your browser, it resolves to an IP, and the steps of finding this IP is what we are going to dive into in the next slide. All right, so we go to the next slide. So we are going to dissect what a domain is, first of all, since we are talking about DNS, the domain name service. So the first one we see the www, which is the one we're familiar with. That's what we call a CNAME inside the record, inside your record. So your name, the .jajo here in this example, is a second level domain. The first domain is the .com, .gh, .org, .net. That's the top level domain. And then there's a dot at the end, which implies that this is the end of, we'll dive into that in further when we are talking about the records. So the dot is to make sure that, this is an absolute link to your domain. So the .com, which is being run by a registry operator, in each country we have people that register the .com, the .ng, the .gh. So that's the main domain, and your name is a second level domain. So whenever we need to resolve this .jajo.com, it goes to the resolver for .com, whoever it is, and then it provides the IP. So now we dissect to how name gets resolved. So we see that the name is resolved by a DNS server. Each of our devices have the resolving DNS client, which we use to resolve. So each time you put an address in your phone and your laptop, the DNS client, which is the resolver, sends it to a DNS server, and then the server sends it to the root servers to look for it. So in this case, I'm just going to do a hands-on practical to do this. So move it to the screen. So just a moment to show this. So we get back to the slide once we are done with these parts. It's left or right. Trying to move to the second screen. Okay, Carrie, I increased it. All right, so here we talk about DNS resolving. Yep. So to resolve a DNS, let's say we are accessing google.com, and in this case, if we use call, which is something that gives us information to get the information of maybe google.com. Okay, sorry, I'm not connected. So you see that the first step is I couldn't resolve it. So without the internet, the first step of internet is to resolve the domain to get the IP. So I'm just going to connect my device. So once the DNS server fails, you cannot access it unless you have the original IP of the destination. So call it, it's a command for accessing a website or a server on the internet, it's a HTTP server. The I is to show a verbose information, so I can show you how the results happen. So we try again. All right, so this is a detailed, I think, no, yeah, let me, I think it's V, it's not I. So, all right, so we see what happens here. So we are looking for google.com, which, sorry, it said that host Google was resolved, and this is the IP of Google. And then this is also the IPv6, and since my device doesn't have IPv6, it's immediate connect first for IPv6, then it connects to the IP4. And then the core, which is this client I'm using, offers HTTP1 and HTTP2. And then it shows what happens and everything. These are details of both. Yeah, but the most important is that we see the IP of Google as it's been resolved. And that's how the resolving work. Yeah, that's the google.com what it resolves to. And we can try this to maybe, I think I have ghana.gov.ng.gh. So if we see this as well, it was resolved. It doesn't have an IPv6, but it has IPv4, which is the two IPs, and it does a round robin, which choose randomly from between each of them, and it chose this one, and then other ones are HTTP related. So here we see how resolving happens, and whenever you visit a website, the IP gets resolved and then loads to your browser and exchange data from the server. So we can also do something like NS lookup if you don't need to load the page. Maybe you just need to get the IP. So in this case, we see zonjaju.com. So we see the server that resolved it, which is this IP from our ISP. I think in this is a Telecel private IP because I'm using Telecel. So they resolve it, and then this is the IPs of this domain name. There are they could do multiple IPs, and when there are multiple IPs, the client, which is your browser, chooses any of them randomly. So it does a load balancing with the two IPs of which one to choose. And then if there's an IPv6 support, it chooses that. So that's how resolving happens on our devices. So we are going to go back to the slideshow to, I think, where I stopped. All right, so the root servers, which are the people that resolved it, are there. And then there's a TLD server. A TLD server is the top level. When I mentioned .ng.gh.com, those are the people with your records. So when you get a domain, you get a record, and that record have details about your domain, or where the record, if you have a record or e record. So I'm going to also give a hands-on practical on this. So we see that let me see. All right. So in this case, let's say we have the root servers. So if we are trying to resolve servers from, there's a command called dig, which we use to find the DNS of a record of the DNS of a domain. So let's say donjado.com. If we do this, it's to give you a more verbose record. This is my IP. And then if I need to find what happens in the background, so there are different servers. So I can say I want to use a resolve with Google server, which is .8.8.8, which is their public server. So what it does here is that Google look for whoever is in charge of .com and finds the IP. And I'm going to show this by if I look at ghana.gov.gh, and then I try to resolve it. No, sorry, .gh. And I try to resolve it with there's a root servers.net, which is all right. So here the first record is the name server, which you see who resolves it. This person has access to the DNS, and that's what I'm going to discuss in the next slide. Sorry. Okay. All right. So we talk about TLD. So in the next slide, we're talking about the cache results, the records that we have. And we are seeing that, Don Jajo has this record of this IP. And for that to happen, for us to be able to resolve it, we need what we call records. So when you get a domain, someone holds the record. So if you buy a .com, I think it's VeriSign or some of these companies, they hold the record of this domain. But for .ng, for .com, .gh, .afric or whatever, they are held locally here as well. So they give you a domain name and then they give you what we call records. And this record contains details about the type of record in your domain. So we have A name, we have AA name, we have C name, MX. These are basic ones, there are many of them. So an A name is a primary one which says your IP is this. So when you say this is an A name of this domain, it means that this is the IP or whatever you're looking for. So the AAA is an IPv6. Since we are migrating to IPv6, so we added a new record called AAA, which resolves to IPv6. And then the C name is an alias. So if you need to say, I need this domain to be alias of this domain without actually revealing the alias. So if you put it on the C name, whenever you visit that, it goes to a specific, the destination domain. And then the MX is for mails. So that's why when you see at gmail.com, in their records, you have what we call MX. So the MX tells whatever a system where the mailbox is for that domain. So that's where you have MX. And then we have TXT, which is a free form for metadata as any other extra data you need to add to the domain. Maybe if I need to, it's used in a case where you need to do verification that someone owns a domain. So you tell them to add a record to the TXT so that you can, if you're able to do that, means you have access to the domain. So it's your domain. And then there's a name server, NS. This is a delegation service. So when in this case, I think the body that registers the domain do not resolve, they don't have the records. What they do is they give you an NS. And NS is to say, when you visit this domain, the real people with this data is specified in the NS. So we call them, registrars and people who, what they call CDNs. They register the record. So when you visit, I think, let me see this, an example. All right. So we can see here, for example, you see an NS. When I said, let me start afresh. So if in this case, I'm trying to resolve .gov.ng, and I'm going to remove this for now. So we see, if we look at this is the answer section, which we need to focus on. And this is the time that the domain should live in a cache. So for any of the DNS clients querying it, it's telling you can cache this result for this amount of seconds before you can try again. So that for subsequent, anytime you need to visit, your device doesn't have to hit the server again to request. So it caches it for 2,000 or 21,000 seconds. I don't know the exact time. And then this means it's for internet. And this is a type of record, an A record. So if you see this answer section, we see that this resolves to 7.6 is as an A name record. So, and then there's an additional one, which if there are multiple of them, it can be round robin and just randomly select any of them. And an A record can have different entries, multiple entries. So in this case, we have one entry for both of them. And this is the IP. So if we need to, in this case, find the NS, you can say, we see who resolves this name. So we see it was Nita that resolves.com.ng. If you need these are public data, by the way, so it's on the internet. So I'm just using this for example. We see that Nita resolves the IP. And if we try to actually find the IP in this case, I want to find ghana.gov.ng and I say, I want to use one of these guys. Okay. Oh, nope, I've put something here. No. So if I need to use one of these guys and specify, this is a DNS server. I think 1, 2, timed out. So think there are multiple of them. So the NS holds the exact record of, okay, I think I made the mistake. See the IP of, oh, sorry, because specified, yeah. So if we look at there, uh, see all the records about this, see the real IP. And in this case, you specify the NS, which is this guy. They hold the exact record of each of the domains. So whenever you're visiting, let's say, um, oh, hold on, the main registrar would point you to an NS. I'm trying to explain it in a very in a very understanding way. So let's try again. I think I have a.root servers.net. So the root server is the one that says yes. So in this case, it says that the top level domain, which is .gh.com, whoever is in charge of it, is this name server. So if we need anything .gh, if you need to find the IP who has the DNS record, the people you should go to are these the domains and the IPs. So it returns the NS whenever you are looking for anything. Now, if you do let's say if I'm doing .ng, the same thing. So it points you the right place to go to, which is nick.ng. If you're doing the same way with .com. So now the journey is that whenever your browser is querying, what it first query is that it goes to these guys to say, oh, it's a .ng or .com. Who has this server? Now this returns that these guys are available for that. So I can also, I thought I did this on my laptop. Let me see. I'm not sure why this happens. Just to give more clarity on this. Yep, I did this. I think I need to, let me reduce my resolution. All right. So this IANA, Internet Assigned Numbers Authority, they're the ones that assign IPs and domains across the world. And that's where you get a root name server where they defined it. This is also on their websites. Oh. So if we need to resolve name, build your own DNS, we see that they have authoritative name servers that serve DNS root zone. So they are the root servers where hundreds of servers in many countries across the world is being tied to. So let's say, for example, if you look at here, the root server, and we see, they have multiple servers. So let's go to, if we need to find more zones. This is something. So these are public data of where to look for whenever you're going to any network, any of the, you see .gh here is here, the one they got you on the command line. So it's also here, any of the countries, if you need to find whoever is in charge of resolving the name. So the root servers are in charge of saying, this is who has the records, the A name, the root name, but we don't have it. So that's the role of NS. So let's go to, if we go back to our slides, that's the slide from the current one. So if I go back to where I was defining, that's the role of NS, and NS is who says who has the remaining records of whatever you're looking for. So it's I think a better way is a document system. A domain is a document that you open the file and say, okay, this is the IP of whatever you're looking for. This is the A name or the NS or whatever. So that resolves it, and then we go to the next one to define this. We see the AA name in this example. So the A and the AA name maps a host name to an IP address, which is the what I defined in the first. So if you look at in this example on jajo.com, we see the record that this is the time to live, which is about, I think it's 1 hour. For this to live in your device, if you want to cache this result and don't come querying for it again, you can cache it for this amount of time. And whenever this amount of time finishes, you can come back to ask for a new one. So, and then this is the type of address, which is usually internet. And then this is an A name record. So this A name points to this IP address. So whenever you visit the root.jajo.com, it gets you this address. And then the www is another a name. And then when it's an a name could be multiple. It means that when I visit www.donjajo.com, I get this IP address. And when you visit again, donjajo.com in IPv6, you get this address. I think I've missed something. All right. So we see a multiple a name with different records. So if it's the root one goes to this IP address, the next one goes to the IP address, and then for IPv6, this is the IPv6. And then if there are multiple of them, in the case of this API, there are two IP addresses for API a name. It takes a round robin, which is random, to select which of the ones you want to use. So we can see an example of this when you run this command. And then if you go to CNAME, the difference between CNAME is an alias. An A name, it points to an IP address. CNAME points to a domain name. So in this case, I want to redirect my www to the donjajo.com, which is a CNAME. A CNAME could also be, you want to redirect my shop to some other site. But when you load this on your browser, you see what you loaded, the address on the bar, but then it's being redirected to somewhere else. So that's what CNAMEs are. And then we go for MX, which is for mail systems. So the records on here, whenever a mail is sent to, whenever your mail client is sending a mail, it looks up for this MX to say, where is your mail servers? If it doesn't have it, then the domain name doesn't handle email. So you get a bounce back. So it looks for this MS record to say, where are your mail servers? And also in MX, there's an extra field called the priority field, which shows which ones to take first. So the lower the priority, the one it goes first to send. If it fails, it goes to the next one till you get the mail delivered. But if all of them fails, then you get a postmaster failed email bounce back. So it's the MS record, and then we have the text record, like I explained initially. The text record in DNS are the ones you can put any extra data for there for domain verification, for if you need to verify that you own this domain, I can tell you just put something in your TS to show that you have access to this. And then the NS, which is a delegation, they're authoritative for a zone. So if you provide an NS, when a DNS looks up, they go to your NS to say, is there someone who can resolve this? So the NS provides, okay, I'm not with this record, this is someone with this record. So it heads down to NS. And so now we've talked about record, we talk about the public DNS resolvers. So we have DNS resolvers globally, they are public ones, and each ISP actually have their own as well. Just like I showed initially, the one resolved by the Telecel one in my phone. They have Google one. Google has a public DNS that anyone could query. You get any of the IP address for any of the devices, domains you're looking for. And then there's also Cloudflare, who provides the built around privacy to say they don't log your IPs or any requests. And to keep in mind that any of the domains you resolve with any DNS, they actually keep record of that. They can actually provide you a CDN IP, so you can't be so certain that's the IP of the server. So that's where CDN comes in. A CDN could resolve to a different IP of a proxy, and then so that's the IP of the domain using the command. And then with dig, there's a command called dig, which is DNS2. It gives you more verbose response. If you need more technical response, like you've seen, it can also give you that. And then it can use it to get different records, the MX, the name, and then find the data in a domain. So this is the payload for dig. Like I mentioned, it's more verbose. It has the answer section, the question section, the query time, and also some additional data at the top of the page to show the type of reports, and also the results, the query time, the server that responded, and all the verbose information. So that's for dig, and I've used it here in the show. So there are also some things worth noting in the command. If you need to also see the trace of who resolves what, you can actually do that with dig. So I can say, let me say dig. I've actually wanted to know this one. That's Africa, and then you do trace. It actually tells you the journey. So you go to root servers. The root servers tells it where next. So if you follow the journey, it takes from the root servers for each of them, and it says this is the guy resolving it. It's a series of guys. the COSA, the DNS node, and then it queries these guys to get me the real one. So when it queries this guy, they point him to another name server, which is the Cloudflare, and then the Cloudflare provides the IP. So there's a journey of where it goes to. So if we do another one for maybe entirely different domain, yes. So the tracing is to trace where it's going from. But everything starts with the root servers.net, which is managed by IANA. So the root server tells it where it should go to, and then the Google goes to GLDT servers, which manages .com, and then it tries a couple of them, and then they are redirected to NS1. Then Google tells them exactly what the IP is. So it's if you need to trace and learn how the journey goes through, you can know that as well. So we would. Sorry. No, it's not. So it's saying something you're going to trace. Why you want to trace something? Oh, I do it often. Actually, when you're doing DNS propagation, let's say you migrated servers and you change the IP. Yeah, you want to test to see if it's working. Yeah. So that timeline of the TTL, the one I said is 3,600. So some of the servers keep this thing. The public resolvers like Google, yeah. So they have to wait for the timeout to go and try again. That's why we have DNS propagation. So you use it to know actually has it been updated on the record, and then you know, okay, you've done your work, and then you wait. So you do query these things as well when you need to find. So most of the time you do find IP. Some of the clients.